Okay, this video is going to be designed to show you how to graph sine and cosine. More importantly, this is going to be a way to do it very straightforward. So we're going to try to keep it so that your graph is just to the right, right? If in the future you needed to, you could essentially do the mirror image and then be able to graph the same thing on the left-hand side, right? So let's just keep it basic. We're going to start by dissecting the cosine and sine graph. So two of the main components that make up a sine or cosine graph or any graph for that matter is, well, of sine, cosine, tangent, right, is the period and the amplitude. So you can pause the video at any time and then just write these notes and it'll help you and me, right, by saving some time. So the period is the length of a cycle, right? And in the way I like to say it's the interval of the graph before it starts to repeat. So let's put that on the diagram so that we could see. So for sine, it starts, pick a point. You can really pick any point, but I really like to start on the y-axis. So I'm going to start right here. And then I travel along this line. And then I ask myself, where does it have to stop before it begins the same process over, right? And that's what we call a period. So if you notice, this point here and this point here kind of terminate at the same level, right? If you were to travel across here. And you would say, well, what about this middle point? But the reality of it is that if you travel past the middle point, right, you'll continue down a different path and then you'll end up with this last point on the right hand side. Now, if you notice, if you pass this point here, you'll start essentially recreating this beginning that was on the left hand side. And that's how you know you've sort of done one full cycle, right? Similarly over here, we start at the middle, at the top, and then we go down. And once we get to this point here, we'll realize that we'll start going down like we did initially. And that's kind of where you can tell that it's a new period, right? So for our purpose, we're just going to worry about graphing one period, right? We don't want to go one period, right? Two periods, etc., etc. Just one period. The next thing that you need to consider is the amplitude. The amplitude is really how high the graph is, and right here it says half the distance between the minimum and maximum values. So really what it's just saying is it's referring to this height here, right? So this is the amplitude, and the reason it refers to this height right here is because if you notice the distance between this top, the maximum part of the graph, and the minimum part of the graph is the exact same distance from the bottom half, right? So the amplitude in this particular case, if we just put a number to the graph, let's just say this is 1, this is -1, then the amplitude is 1, right? So it's the distance from this point to that point. That's 1, and that's 1, right? So that's why they say it's half the distance between the minimum and maximum values. And I like just to refer to it as the highest and lowest point of the graph, right? So with that being said, I think we've covered all the little parts. So let's jump into trying to graph it ourselves. But before we get there, actually, let's just take this moment to just make a quick note for ourselves and future reference here. So if we stop to just trace this part, let's just label it and remind ourselves that that's just, well, let me rewrite that. It's just a period. And this part here is the amplitude. And to keep it sort of nice and neat, I'm just going to say that that's the amplitude. Right? And I can do the same with cosine, but for the cosine, I just really want to pay attention to the period, right? I think amplitude, it's a little easier to understand, and we got it. Cool. So now to start graphing these, you kind of need to break the actual function down. So if we go down here, we'll see given f of x, a times sine bx, and then a cos bx. The amplitude using this function is just the absolute value of a. We don't care if you remember back when we were graphing other functions, there's a negative in the front. We don't care about that. We'll notice based off of our examples how we run that. But all we care is for the positive or absolute value of a. The period for sine and cosine is going to be, it's going to be 2 pi divided by b. Now, the idea that it's 2 pi is for two main reasons, right? One, cosine and sine doesn't have like a vertical asymptote, right? There's no value within the unit circle that you cannot plug in into cosine. But more importantly, it's 2 pi because if you remember the unit circle, when you make a full circle, you start at 0 and then you go all the way to 2 pi. And then once you break 2 pi again, right, you're just repeating the same circle. So really one full cycle for sine and cosine is 2 pi. So with that being said, let's start to focus on these functions and being able to graph them. Now, I've already pre-written these steps on the side, so please pause the video and you can pause it along the way, right? But I will break down the steps one at a time, okay? So follow along, pause the video if necessary, and before you know it, we'll be on the same page. So step number 1 is just determine the period and amplitude. So I'm really referring to this part right here, right? This is what I really need to get down. So for the period, we have, let me pull up a different marker here. For period, so you could say just PR for period, right? You don't have to be so specific. The period is going to be 2 pi divided by b. And b, just to be specific here, b is whatever's in front of the function itself and x. So b is whatever's in right behind x, but right after cosine. In this case, again, it's whatever's after sine but before x. Anything in between that qualifies as b. So in this case, in our example, just 4. Over here is going to be just 5. Over here is going to be 1/3, right? So let's start with that. 2 pi divided by 4. So my period fully reduced is going to be, it's going to be pi over 2, okay? The next thing I'm going to need is going to be the amplitude, and that's usually the easier one. Amplitude A, right? You could put the absolute value bar, but you don't need to. Just pay respect with that to that, and that's 1, right? In front of sine, or right behind it, however you want to refer it to it, that's just 1, right? So at this point, step 2 is just construct the graph and place the period and amplitude. Normally in a normal math class, right, that if you're taking this course in college, you normally have to draw this graph, but for our purpose, really, you can just get away with one side of the graph. So in this case, we're going to actually stick to the right-hand side, okay? If you truly get this down, you can really reproduce another period, right? If you're asked to do 2 periods, and then you could do 1 period to the right and 1 period to the left. That's always going to be easy because you just literally reflect it over the y-axis, except obviously if you have the sine function, it wouldn't be necessarily a reflection, but you get the point, right? You could continue the period to the left, and it's very easy to predict, right? Cosine, on the other hand, is a true reflection. So just keep in mind how I'm using the word reflection, okay? Cool. So I'm going to start by doing step 2. So I already constructed the graph, placed the period and the amplitude. So period and amplitude. Amplitude, we're a little short on space. So right here, though, we can fit -1 right there, and we can fit 1 up here. We got the amplitude down, but if it were 2 or 3 or 5, then obviously you would want slightly larger gapping so that you can really tell the distance between the numbers. But here it's just 1. Cool. So now we're gonna graph the period. The period, take this, and the first thing you want to do is place it all the way to the right. Okay, this is kind of be your end of the period, right before your graph starts to repeat itself again. So you want to come up with 3 points. The middle point here, this first point here, and this third point here. We're going to work at finding the middle one first, followed by this first one, and this first one is going to be the key to everything. So let's begin, right? So we're going to go ahead and just find this point here, which is the halfway point between 0 and pi over 2. So the best thing to do is literally just half pi over 2. So pi over 2, right, divided by 2. And then you can do your keep, switch, flip trick that you've learned in grade school, right? So it's pi over 2 times 1 over 2. So if you do the multiplication there, it's going to be pi over 4. So that's pi over 4. All right, I'm not going to be too caught up on how do you get the fraction part, right? Please look at just finding values of fractions divided by a number, and then you'll get this process down, okay? So then we're going to go ahead and find this point, and basically that is the halfway point between 0 and pi over 4. So we're going to take pi over 4. I don't want to write there. You see, I'm taking the space of the graph, so I'm going to write it on the top left. So pi over 4 divided by 2, right? Or let me write it the other way around. Pi over 4 divided by 2, and that becomes pi over 4 times 1/2, and that's pi over 8. So right here's pi over 8. And I'm kind of writing it crooked, as you can see, because I'm running out of space here. Now, this is the very important part. This is what's going to save your life, okay? This is your first step. So imagine just taking any step, right? If you took a step, you'd say, one step. But you have to be cognizant of what's happening here. Our one step right here, our first step is pi over 8. So pi over 8 is what we call our step, right? That's our first step. So check this out. This is pi over 8. So if you take another step, that's just going to be pi over 8 plus pi over 8. And what is that? That's equal to 2 pi over 8, which simplifies to pi over 4. And there you go. You see, by doing that one step at a time, we've now got our second value there, which was pi over 4. So guess what? Pi over 8 plus pi over 8 plus now another pi over 8. So this value right here, we just took 3 steps, so that's 3 pi over 8, and that's literally what it is. So your third step there is 3 pi over 8, and just to convince you, to get to the last one, you would have had to take 4 steps, so 4 pi's over 8. And that reduces to canceling out, that's 2, that cancels out, that's 4, and that also cancels out, and it ends up being 2 down here, so pi over 2. So you see, when you find this middle value and then use that to find this first value, you've now found everything. You found your first step, so you can take the first value and come up with the second one, come up with the third one, and then the last one. All right. The last thing you want to do is graph sine or cosine. So this is where you really want to take ownership of remembering how sine starts. Sine of x will always start at the origin. Obviously, if there's a shift, right, a horizontal shift, that doesn't happen. But since there's no shift here, we're gonna, play it like this. As you get better, you'll realize the different patterns that exist. But so it makes this kind of like little sideways S shape, right? Whereas cosine makes this sort of U. And partly is because this cosine is symmetrical, but we'll get to that later. So in any case, let's just graph it. So we have sine instead of cosine, so we take note of how it looks. So then we start here at the 0, and then if you really want to just get this down, you go to the next value and it's 1 up. Then you go to the next value and it's 1 down. And then you go to the 3 pi over 8, which is going to be 1 down now. Now I'm trying to preserve the numbers, right? So I don't, ruin everything. And then I just go 1 up, and that's where I finish, right? And it creates this S pattern. Now I know that these are baby steps, but if you really get this down, you will be doing just fine. Now I'm going to pause this video because this video was mainly for the notes, and I'm going to make another video doing a few more problems, right? So please take the opportunity to pause the video, go back and really get this down before you move to the next video. And also give these next few problems a shot using the same process to build that level of confidence you need to to really say that you got this. So I hope this video helps.